So I think it's been a week since we did a CB video. There has been a CB in between, but unfortunately it didn't get recorded owing to a power glitch. And that was a Midland 98, something like that. We didn't get anywhere with it because it was so riddled with dry joints. It wasn't going to. I spent two 90-minute sessions. We've got some things working on it, but it wasn't ever going to be reliable without taking out every component, cleaning the parts and putting it back together, which is cost prohibitive on what was once a $39.99 set. Now we've had a new bench mat, so of course I had to show we've got a new bench mat. I think Mr. Chippy's had a new bench mat too. What button shall we press? How about that one? Will go back to normal. LCL 2740. Had a Russian viewer say he's got problems with an LCL 2740. Or he certainly commented on an LCL 2740 and showed problems with his. Now this is a UK version, and so he's FM only. But that's not where his issue is. He goes into transmit and his VCO volts drop. And it did strike me in bed the other night that I thought, I wonder, because I noticed he was running off a battery. That battery is going to be 12 volts. And I just wonder if there isn't the current when it actually goes into transmit, so it then cuts out. We're going to try and replicate that fault. First of all, we're going to have to make a mic up because we haven't got one. So that's the 5-pin type of a unique pin out to this type of radio. I've photocopied I've got a scan of the photocopy of the instruction book here. It has the circuit diagram, the layout. Dear CB friend, your CB friends are enthusiastic and have pleasure in each conversation. You want to listen to what we can hear on 19 coming from Nottingham. I don't think they like each other very much. So, we will start by making up a microphone. Alright, all these DNTs and LCLs from this era are now getting unreliable 40 years on. And we've come to the conclusion that only about 50% of them can now be repaired. So some sets, it's 99%, like the Cybernet series and the Uniden ones, as long as the TC9119 hasn't been killed by some silliness. But and the Maxcom ones, very reliable, but some of these, shall we say, more off-brands with poor quality printed circuits in the first place aren't always resurrectable. And especially if they've been messed with. Now this looks quite a good one. It's got a full length power lead. I've got no notes about it. Our database has no notes of its origin, so I presume it's come in a box of other things. So the pinout. Right, well, if I get our chart, which isn't always accurate, so LCL 2740 says it's pinout number 12. So from left to right, audio, nothing, common straight braid, nothing, transmit PTT. So in this case you're not going to have the receive because it has a relay in it, so it does the receive for you. But that means you can't use it with a telephone handset. Boo-hoo. Who uses a telephone handset? You'd really want the police to think you're on a phone, wouldn't you? So I'll go and get a microphone and an expensive plug, unless that one's already been wired. You never know. It doesn't matter which set I've got on the bench. If there's a 5-pin DIN mic which hasn't been labelled, it won't be the right one. I'll just pop the power supply on, pop the radio on, turn it to channel 20. I think there's a planet where all these knobs go. If there's a bar out on the display, no there isn't. I was going to say that'll be as far as it goes. So put it on channel 20. Let's see if this mic is correct. No. Right, I'll get all the parts together and we'll make one of those up. Like this before, this is awful. No, our wholesalers haven't got any mics, and I thought I'll see if I can get some direct from China through Alibaba or AliExpress or one of those. And so these Superstar mics have turned up, and they come with a 4-pin mic plug, which is normally we buy mics with an open end and we put on whatever plug necessary. And these are what you would call wired unidens. I've chopped the plug off, which we can of course reuse. And when I've come to do the plug end, it's an 8-wire cable. So I'm expecting 3 wires and a braid. It's 8 wires and no braid. So how does that screen the microphone signal? I think the answer is it doesn't, and as you move the mic around you get increasing, decreasing hums. So what I've done is connect the 3 wires we need, which is transmit, earth and audio hot. There's no receive on these, as I've said before. And then what I've done is to short all the rest of the wires together, and we're going to trap those or solder those to the shell of the plug. Yeah, if I put that through there, that's the way to do it. So this blue one, which would be receive, we'll connect to earth. And so then we are effectively using all the unused wires as some type of earth. So I'm hoping that they produce enough of a Faraday shield effect to not make this all hummy and horrible. So I won't be buying any more of those. I mean, the biggest difficulty is we struggle to get mic leads. I can get 3 metre long ones, but I can't get 1.8 metre long ones. And so I thought, oh right, you know, these mic, and they don't work out cheap. And then we find that they've got an unsuitable cable on them. I'm looking forward to seeing how this sounds, because it'd be humming like nothing at all, especially if I hadn't taken that action. So we'll just solder this wire back on yet again. And we'll come back to you. Right, that's the radio open, and let's put it back on. Well, it hisses, and when I press to transmit, oh, it actually transmits. Let's put picture in picture, and then oh, it is on. You could see that. It's just doing under 3 watts. Okay, now then, thinking about the Russian gentleman. Did he say pin 8 he's got 1.6 volts? One, 2, 3, 4, 5, 6, 7, 8. And we've got 7. If it was pin 8, which we need to look at. can't even remember which the lock detector's on. Anyway, here goes. Now I notice he's running on a 12-volt battery of a motorcycle size. And I'm just wondering if he's somehow not got enough current available. I'm going to turn my power supply so that it cuts out at something like 900 milliamps. It still doesn't do what his is doing. But it's still transmitting on frequency even when it's current limiting at 350 milliamps. Right, well, we'll start with setting... I'll go back to normal power. We'll set up the VCO and then we'll try and fiddle with the VCO till we get the same fault that he's got. So it draws 1.1 amps at just about 3 watts. So the first thing we need to do is to set the 10.24 reference oscillator, which is this one and the corresponding trimmer there. So put that to one side. We could use the frequency counter, but it's quite convenient to use this portable oscilloscope. So I'm just using this as a frequency counter, especially if I know how to switch it on. Let's see whether we can just get onto the right pin. So it's going to be pin 3 or 4. 10.2388 on pin 4. So it's pin 4. I can never remember which one it is. I don't see enough of these, luckily. So we need to be able to bring that up to 10.24. And you've got to do this before messing with transmit or receive. Why doesn't that fit? We've got exactly 10.24. So this crystal is fine, it's gone up. So that's your very first adjustment. Then you can do the transmit one. The transmit one is straightforward. You use your frequency counter on your, which you normally would do for when you're tuning up. We can put that away. So your next one is to transmit. So we'll go over to the frequency counter on this test set. And we should have the channel 20 frequency for the UK, 2779125. As you can see, it's slightly high. It's in tolerance, but we'll bring it back down. I think it's the right hand one, but I might be wrong. That's going higher. That's going lower. I'm being a bit fussy on this. I mean, I could stop the. Yeah, we've got it bang on now. So very important. That one is 10.24, monitoring pin 4 of the PLL chip. Then we can set the transmit one, which is there, and then the left hand one is the receive one, which we have to use a marker oscillator with. So that's receive. Let's forget about that for quite a time. You need to do it with 2 signal generators in effect, because what you're going to do is you're going to put your signal generator on the frequency you want. In our case it's 27.79125, and then you're going to put your marker oscillator on one of the 2 IFs, preferably 10.695, but you can also get away with the 0.455, the 455 kilohertz IF, if you haven't got a marker oscillator that will do 10.695. We'll be using a second cheap signal generator to generate that in a moment. So that is the important bit. Got to set that, then you set your transmit, and then you can worry about the receive later. It's not like most sets where that would affect transmit but it not receive for 6. So got to get it right. So the VCO is going to be L4, isn't it? Now it says as a test point, resistor 12. Just get magnifier on this. I wonder if this is the test point for the phase lock loop. Between resistor 32 and resistor 33, it says is a test point, and surely that must be the VCO. What else would you want a test point for? So between 33 and 34, that junction. Now this is mirror image just to make it more fun. So it's 33 and 34. 32. There's 33. (32), 33, follow the trace. Well, I think we'll look at this another way, because I haven't found 34 yet. Might be easier to look at what else is on that junction. So I've got diode 5 and capacitor 32. So diode 5 is the far end of the resistor, capacitor 32 is the far end of the resistor. So it's the opposite end. Oh, there's 34, there's 33, there's 34. So it's linked or printed its way around there somewhere. 34, 33. So if we monitor it at resistor 33, that end. So this is mirror image, as I say. So now we'll put it into reality. Resistor 33 is there, and so it's there is our test point. Okay, we'll get the meter back. See, I've never done this, but I've never had to do this. So let's have a monitor. And we've got 4.94 volts on receive, and we've got 2.7 on transmit. You know what, I think this is going to be the VCO monitoring point, because what else is it going to be? So we said, I mean, clearly surely that's the VCO coil. So which one is that? As we look at our mirror image thing, L6. So L6. So that's going to be our VCO coil. So let's see what happens. I want to transmit. So I'm going to adjust this coil. Do I need to? Yes, it's our VCO adjustment. So now it's gone out of lock. So whilst monitoring, there we are, clickety click, it's coming into lock, dropping off the other end, yep. So theoretically, I would suggest it's going to be, if it's halfway through the band, let's try 3.5 volts. Okay, now I'm going to move it to channel 40. God, I'm going to need a bigger screwdriver than that. Just when I need a channel selector knob, there isn't one. So now on channel 40, we've got 4.6. So where are we on channel 1? We're at 2.6. I think I'd like that a little bit lower. If it was in line with normality, let's adjust it to 2.3. So 2.3. Go back to channel 40. So we've got, 4 volts for channel 40, 2.3 volts for channel 1. So hopefully we're somewhere going to be around 3 to 3.5, I would say, for channel 20, which is where you'd set it. So I've never had to do this in all the years. Three. So yeah. So I would say that just over the 3 for channel 20, and then check that it's around 4 point something, certainly under 6 for the channel 40, and above 2 for channel 1. That seems sensible to me. So that's the VCO test point. I'm going to zoom in so we're absolutely clear. So this resistor here, which looks like 4.7k, says test point on the circuit. So at the junction between resistor 32 and 33, and that turns out to be the left side of that coil. We're monitoring that point for that VCO voltage. Now on receive, I don't expect there's a separate one. So our receive lineup is L2, L3, L4, which I can see straight away. So where are they? Let's have it that way on. So they're all up there. So I'm presuming we'll check that 13, 15, 16, 17 are transmit. And 12. Oh, I think that's fixed. 13, 14, 15, 16, 17. 13, 14's fixed, 15, 16, 17. So there are our transmit ones. We'll just check that these are absolutely receive. These are going to be IF. L18. What's that doing up there? So crystal 2 so crystal 1's the 10.24, crystal 2 is the receive one, and crystal 3 is the transmit one. So L18 is going to affect receive. There's our transmit one and the adjustment. Now I'm satisfied we've cracked it. So there's the VCO, there's the test point. You should be able to adjust that for around the 3.5 volts on channel 20, and that should bring it into lock. Otherwise, you've got to check that you've got sufficient current available, because that could cause it to drop out of lock. If the radio tried to transmit and it dropped under 12 volts, then it could start to chatter the relay because of insufficient power as the PA tries to come in. So I think that's going to sort your problem out. Careful adjustment of L6 monitoring that resistor, resistor 32. Right, let's have a look at our transmitter. So that's peak, just under 3 watts. That either is broken or needs a bit of soldering iron treatment. No, it's not broken. It's now a tiny little smidging away from 3 watts. That's now 3.5 watts. We'll just recheck this one. That's fine. And then we'll just look at these two here. That's 3.9 watts. That's 4.1 watt. If there's one in there, it's going to be the 54 meg trap, so that doesn't want adjusting. I think we'll just tune that down a fraction. We'll have it 4.00001. Well, that was straightforward. It's doing 4 watts, which is damn sight better than a lot of modern sets. So I think we can put the test meter away. So it looks to me like this isn't a faulty set, it just needs a tune-up. The fact the 10.24 was miles out would have been some very peculiar results on receive. Now then, what does the meter say? The meter's about where it should be, but let's see what the adjustment is. I think it's those two, to be honest. So if we look at the transmitter, it is monitored. And it's resistor 36, I think. This trouble, you know, needs. It's a photocopy. It's a scan of a photocopy and reading the numbers. It's 98 or something like that. So it's what? It's that one, 98. So it's that there. That's bang in the middle of the strawberry patch. I love that phrase. So let's see what it's doing on low power. It is doing 700 milliwatts. Hopefully that's adjustable. It is. It's 107. I think it's that. It is. It's that vertical one there. That's the tool on the floor. .400 milliwatts. It's annoying when this is mirror image. You could always photocopy it onto acetate, or you could always scan it and reverse it and read all your letters backwards. It's supposed to be red, is it? So we've proven that all these are transmit. And if I knew where my yellow one was. Yeah, right. So now let's look at transmitted audio. Haha, this is going to be interesting with this mic. Wallow, testing 1, 2. It's about 2 kilohertz. See what it sounds. Oh, I'll tell you what, we'll set this up first. Then we'll see what it sounds like. So what's deviation going to be? Well, microphone, this is all the speech processing, so it's going to be 84. .84 is the lower one. That's deviation. Let's get the oscillator out. Pop that up a fraction. That's already at full. It is acceptable, that. Wow, it's 2.1. Wow, it is acceptable, only just. Hello, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. I tried to think what the hum would be like if I hadn't turned the rest of the wires into a Faraday shield. At least the mic works. I'm not going to start altering the radio, it'll stay with this mic now. But I know these radios are capable of greater deviation than this, so I think it's with the microphone arrangement is without the screen cable is what's dragging this down. So that only leaves one adjustment left, which is going to be the receive meter. So we've done transmit, it's very satisfactory. We'll go over to receive. So I'll set the signal generator to channel 20, 79125. Got my eye on the time actually, because I've got a Morse thing to do in a few minutes. With Stuart. There we go, 2779125. We're probably going to have to set the frequency first, so I'm going to have to take a break and do the Morse. Just see if it is actually receiving anything. I mean, the answer is it's nice and sensitive, but it's going to be off frequency and it needs adjusting with that trimmer. So I'll show you how that's done when I come back from my Morse practice with Stuart. Okay, back to the recording. So on the receive, we've heard it making a noise, and what we're now going to do, we've got 10 point, so we'll start from the beginning. On the signal generator, as usual, we have 2779125, which is channel 20 frequency for the UK system. Okay, so that's what's on the signal generator. Let's just knock that to see whether we can actually get the exact 5. There we go. So then on a cheap Chinese signal generator we've got here, we've got it set to 10.695, so that's the IF. So what we're going to do is take the internally generated FM tone off the radio from the signal generator, so modulation off, and this doesn't have modulation, the other one, so we'll dangle the probe. Do you know it sounds nearly spot on frequency? So can we hear that beat note? Just the trimmer to null it. See, we can make it worse. Null. Or worse the other way. So now the radio is spot on frequency. So we'll turn the signal generator back off. So 10.24 was miles out. Transmit was slightly high, but receive was virtually spot on. This radio would have worked fine on receive without me doing that adjustment, but it's the first time I think I've ever seen one of these which has been on frequency, so it's a bit of a faff because you're having to use that second signal generator. Okay, so put the tone back on the normal signal generator. We'll switch the oscilloscope on, we'll switch the bench light off, and we'll go over to the oscilloscope and set the detector. We'll put an S9 equivalent signal on, so we've got a meaningful trace. It's a bit lopsided, but there we go. Which is the detector? Can't remember. a bit funny on these sets. I'm sure it's a bit funny. It's L4 by the looks of it. But so if that's L4, what does L5 do? We'll probably have to fiddle with both. So L4, L5, both those. I bet we have to fiddle with them both. Right, so we'll start with that one. So I'm looking for maximum recovered audio plus best shape at the same time. No, that doesn't affect it. So it's that, it is just that one. Normally the filters are different. Is one normally D and the other G? For some reason they're not on this set, so I'm not sure what's happened there. What does it say? Oh, it says G on both of them. Okay, fair enough. So that's set that. So we've got maximum recovered audio for the best shape. Nearest to sine wave, in other words. So we'll now go over to the synod meter. Switch the bench light back on. We'll go through the rest on synod. So we're now going to cut the signal down, because at the moment, of course, it's saturated, so we need it to be about 4 decibels showing on there. Whoops, squelch just come in. So we'll take it from there. Wow, it's already very sensitive. Oh, that's because I'm in a wrong position. That's why. Check that with the biggest signal. I think that's as far as we're going to get. So it's not particularly brilliant. 0.75 microvolts for 12 decibel synod. But then they're not particularly brilliant sets. No, I think that's what we're going to get out of it. So let's see what it says we would get. Better than 4.4 for 10 decibels. It's about 0.52 for 10. We're not going to get any better than that, and I don't think it matters at all. That's been tuned meticulously. Let's make sure these are where they have wax. There we go. Just see whether we can improve the shape on on that again. .74. Right, so back to an S9 signal and we'll set the S meter. So at the moment it's showing about S9. So we know the only control left is that. There we go. You've got this local DX thing. Let's drop the sensitivity. So this is 0.3 of a microvolt. Yeah, and that would knock it off. So squelch isn't adjustable on this radio. Let's see what it can squelch out. 10 microvolts. It's a bit wishy-washy squelch, but it does work. And it has the channel 3 light. Good. Well, I think that concludes it. We're there. So, because this is all back to front, we know that's the detector. So, we know these are receive. Oops, what am I doing? Craning in the filters. All receive. And you get cores in these two on this radio. Don't know whether that's supposed to have a core, but we're already doing the 4 watts, so that's fine. And if we got a yellow pen, we'd have put the VCO in there. So there you go. So it's test point is there, which is resistor 33. So R33 is test point 1, 3. What did we say? 3.2 volts, channel 20, TX. Right, I'll put this back together and we'll see if we can hear anybody talking 30 miles away. Okay, so now we've put it back together. '19 or Roger. That sounds pretty dreadful. Okay, there's people out there, but you don't know whether people are using naughty radios and whether they're off frequency. So until we do an on-the-air test, we won't know how good this sounds. But they're not the best set in the world, and Wood Butcher? Who's Wood Butcher then? Right, so we'll await Mr. Chippy. We'll do an on-the-air test on that, and hopefully that's sorted out the person who inquired's problem with his VCO. Thank you for watching the LCL 2740 FM UK model from 1981.